We're at the Carnegie Institute of Washington, D.C. in the late 1970s, just as Dr. Vera Rubin is noticing something extremely peculiar. She's been studying clouds of interstellar gas as they orbit around the edges of distant galaxies, and she's realized that they're not obeying the generally accepted laws of gravity. Now, according to both Newton and Einstein, the gravitational forces that objects exert on each other decrease as the distance between them increases. In the context of Dr. Rubin's work, that means that the far-flung gas clouds she's studying should have far less of a gravitational force exerted on them, and therefore move more slowly than those closer to the center of a galaxy. What she found, though, was that it didn't matter how far the gas clouds were from the centers of their galaxies. They all moved at the same rate, and this indicated that something, somehow, was generating enough extra gravity to bring those farther-flung gas clouds up to speed. And that something is what we now call dark matter. Dark matter has never been seen on any telescope, and it has never been directly observed in any way. We do know that it exists because although dark matter is a master of stealth, like some kind of cosmic ninja, we can deduce its existence by observing the effects of the gravitational forces it exerts on its surroundings. But the fact of dark matter's existence is really all we can say about it with any certainty. Everything else about it, what it is and how it works, is a mystery. One of the theories about what dark matter is that it's some kind of particle that we haven't yet managed to detect. Now, some proponents of this theory claim that the reason we haven't detected dark matter yet is because it's simply normal everyday matter, but that it's caught up in hard-to-find non-luminous bodies such as brown dwarf stars and supermassive black holes. But it could also be true that dark matter is made of a kind of exotic particle that has strong gravitational interactions with the visible matter, making its presence easy to deduce, but very weak interactions with light, making it nearly impossible to directly observe. These highly theoretical particles are broadly and hilariously classified as WIMPs, or weakly interactive massive particles, and they're generally assumed to be non-baryonic, meaning that the fundamental components of dark matter are assumed to be completely different than of visible matter, which is mostly made of a class of tiny particles called baryons. Other scientists think that the laws of gravity on a cosmic scale are at least slightly different than those we've observed in our solar system, just like the normal laws of physics don't apply when you go subatomic. They think that all of the issues we've attributed to the influence of dark matter, like the velocities of Rubin's gas clouds, and the fact that a lot of galaxies don't contain enough visible matter to hold themselves together gravitationally, are due to us applying an incorrect model of gravity to the universe, and that those issues can be resolved by modifying it. The year is now 2019, nearly 50 years after Dr. Vera Rubin's experiments. Dark matter is still a mystery, but the questions it inspires are being investigated by thousands of researchers in hundreds of institutions worldwide. And although we may not have the answers yet, we will someday.